We're going to define atomic number, mass number, and atomic mass or atomic weight. The atomic number is the number of protons. This is really important and foundational, so I want you to spend some time on this slide, even if you want to skip over it. I want you to make sure that you understand this slide because there's going to be a lot of exam questions on this because this is a really important concept for understanding everything else that I've talked about. For example, the periodic table and the numbers that are in the periodic table. So just to reiterate, the atomic number is the number of protons in an atom. That's its atomic number. The mass number is the sum of the protons and the neutrons. Remember that protons and neutrons are what gives an atom its mass. Most of the mass is tied up in protons and neutrons. There's no atoms that we know of that have 2,000 electrons, and so there's no atoms where the electron contributes, or the group of electrons that it might have contributes significantly to its atomic mass. So the mass number is the sum of protons and neutrons. The atomic mass, also called the atomic weight in some of the older literature, is the average mass of all the naturally occurring isotopes of an element. We're going to have to define isotopes later on, but just to hold on to that thought for a moment, come back to this after you learn about isotopes, and this will make more sense. But atoms of a particular element, like an iron atom, can occur in a lot of different forms that have the same number of protons and the same number of electrons, but different numbers of neutrons. And we call those different numbers of neutrons isotopes. And those different isotopes have different masses because of the different number of neutrons. So when we average all those out, we get the atomic mass that we see in the periodic table. So the first one of these that we're going to look at in order to better understand this is the hydrogen atom. Because it's the simplest atom, hydrogen atoms are the simplest atom, and so hydrogen consists of one proton, one electron, no neutrons. That means that the number of protons, remember, is the atomic number. And how many protons does this hydrogen atom have? This hydrogen atom has one proton, so its atomic number is 1. That proton has a mass of 1, so the atomic mass, or the mass number, is 1. The diameter of the hydrogen's nucleus is about 10 to the minus 13 centimeters. The diameter of the electron cloud is about 10 to the minus 8 centimeters. Remember that we saw this earlier as the diameter of an atom. We said that it was 10 to the minus 10th meters. And if we convert centimeters to meters, we'll find that 10 to the minus 8 centimeters and 10 to the minus 10th meters are the same dimension. And so that's how big a hydrogen atom is. That's why we said that was the size of an atom. So as we go back to the periodic table, we notice that these blocks not only have symbols, and that the symbols are arranged in a pattern that we'll get into the depths of later on, but that we also have numbers here. We have a number that's centered at the top of each block, and that number is called the atomic number. So the atomic number is found at the top center of each block. This is the symbol for vanadium, or V. The atomic number is 23. That tells us that vanadium always has 23 protons. Remember, that's the definition of atomic number. Vanadium occurs as different isotopes that have different numbers of neutrons, but the atomic mass, or the atomic weight of vanadium, is 50.942. That tells us that the most common kind of vanadium atom has 23 protons, and it has a total mass of 51, because 50.942 rounds up to 51. And so the remainder, the other 28 atomic particles, must be neutrons that contribute a weight but not a charge. So this quantity that we define, the atomic number, is in the top center of each block of the periodic table. The symbol is dead center in each block of the periodic table. And then the atomic mass or weight is in the bottom number of the periodic table. Let's take another one just to make sure that you understand this. Let's take iron, which has an atomic number of 26. Its name is iron. It has a symbol of Fe, which is Latin ferrum, so it's short for the Latin word for iron. It was known to the ancient Romans, and they knew it as ferrum, so that's Fe. And the atomic mass of iron is 55.845. We're going to use that number in explaining things in just a few minutes. So this is another look at the same thing, just a little bit cleaner design of a periodic table. Again, the atomic number, the name, the symbol, and the atomic mass are shown in this slide. Now, another way of symbolizing these elements is to show the atomic mass or the mass number as a superscript to the left of the symbol of the element. And so this is a superscript, so it's higher, slightly higher than the level at which the symbol sits at. So we'll call this 16 oxygen or oxygen 16, which is an isotope of oxygen. Sometimes we'll show this as the number of protons as a subscript here in front of the atomic symbol, and that's the atomic number shown here in red. Remember, red is the color we're using for protons. So because it has 8 protons, this atomic number is shown here. 8 protons plus 8 neutrons make 8 plus 8 is 16. That's the mass number of oxygen 16. So this is an isotope of hydrogen called oxygen 16. The reason we need to become familiar with this way of symbolizing things is because these atomic numbers, mass numbers, and atomic mass are frequently shown in nuclear medicine. So if you're writing up an order in the radiopharmacy department for a radiopharmaceutical, you may get an order for calcium 47, written superscript 47 and then followed by the symbol Ca, which is a symbol for calcium. We know that has 20 protons and 27 neutrons. We know that because the atomic number of calcium, and we can refer back to the periodic table if we want to check this, the atomic number of calcium is 20. That tells us the number of protons. The total mass of this isotope is 47, so the mass number is 47. And so 47 minus 20 is 27, so there must be 27 neutrons in this isotope of calcium. We also use technetium-99, or 99 Tech, it's sometimes called. That's shown in the upper right-hand corner of this slide. We use iodine-131, especially for ablating the thyroid gland. Remember, we learned in Module 1 that the thyroid gland has a lot of iodine, so that's I-131. We use xenon-133 for respiratory studies, and so that's a superscript 133 followed by the symbol for xenon, which is Xe. Those are the first 2 letters of the name of the atom, xenon. Now, returning to that hydrogen atom, okay, we notice that the hydrogen atom, the most common kind of hydrogen atom, or hydrogen 1, has no neutrons, just 1 proton and 1 electron. Hydrogen's atomic mass, however, if we look at the periodic table, is 1.01. And we're showing in this slide how it is that we got to that. What you'll notice on this slide is that there are exactly 100 hydrogen atoms that are symbolized on this slide. 99 of those hydrogen atoms have 1 proton, 1 electron, no neutrons. So that's the hydrogen 1 that we looked at earlier. But every once in a while, in fact 1 out of 100 times, we encounter an isotope of hydrogen which is called hydrogen 2 or heavy hydrogen or deuterium. It goes by all those names. That has 1 neutron, 1 proton, and 1 electron. Because it has one proton and one electron, it's still hydrogen. It's still the chemical element hydrogen. It's still an atom of hydrogen. But because it has a neutron, it has extra mass. That's shown down here in the lower right-hand corner. So if you look carefully, you'll see that this hydrogen atom has one proton shown as a red sphere, one neutron shown as a blue sphere, and an electron shown as a cloud surrounding it. So if we count up all of the heavy particles on this slide, we'll count to 101. There'll be 99 protons in all these other atoms of hydrogen 1, and then we have one more proton here that makes 100. Let me get my pointer back. We have one more proton here that makes 100 and one neutron here, which makes 101 heavy particles. We divide that by 100 atoms on this slide, and we get an average molecular weight or an average atomic weight of 1.01. So 1.01 is the atomic mass of hydrogen. The atomic number, the mass number, the atomic mass of several common elements, the ones that we had to learn anyway, are shown on this slide. And we can also start to see the shell configuration, which we're going to talk about in just a minute.